Question 1. A rocket is launched vertically upwards from the ground. The rocket travels with uniform acceleration. From rest, which is the initial velocity is 0, and after 8 seconds, which is the time taken, and the speed, which is the final speed of the rocket, is 120 meter per second. For part A, to calculate the acceleration of the rocket, so the acceleration equals to the final velocity v minus the initial velocity u divided by the time taken. And acceleration equals to the final velocity, which is 120, and minus initial velocity, which is from rest, means 0, divided by the time taken, which is 8 seconds. So the acceleration is 15 meter per second square, which is the unit. So 1 mark for showing the mathematical formula and the substitution, and 1 mark for the correct answer with the unit. For part B, on figure 1.1, draw the graph for the motion of the rocket in the first 8 seconds. 8 seconds, which is the time taken, is symbolized by the letter T. Okay, from the previous one, the initial velocity was 0 from rest, and the final velocity was 120 meter per second. And for the third one, which is the time taken, 8 seconds, as we mentioned before, to determine where exactly the 120. So we divide from 100 to 150 into 5 sections, and then we draw exactly the 120 is after 2 sections, and we draw the horizontal dotted line from the 120. Then to go to the time taken on the x-axis, and you divide as we did before and along the y-axis, so from 5 to 10, and then we mentioned here this is the 8, and we draw the dotted vertical line. Then once these two lines they cross out, so we can draw the straight line from 0 as a starting point, which represents the u, the initial velocity, and then ending to the final velocity, which is 120. And the straight line here represents a constant acceleration. It means the change in the velocity along the y-axis with the time taken is constantly. Part B, triple I, from time taken 8 seconds to time 20 seconds, the rocket rises with increasing speed but with decreasing acceleration. From time 20 seconds to time 25 seconds, the rocket has a constant speed and less than 200 meters per second. On figure 1.1, draw the graph for this motion, and the question has 3 marks. Before answering the question, I have to go through a quick revision here and right to the question, showing the relation between the speed on the y-axis and the time on the x-axis, and there is a straight line starting from the origin and showing increasing the value of the speed with the time taken constantly, and finally this one represents a constant acceleration. For the second graph, showing the same relation, but the straight line is not straight, becomes curved line. So there is an increase in speed and with increase in the acceleration, increasing gradient. The examiner is asking to show increase in speed with decrease in acceleration. Okay, so the third graph here for the speed and time, but the curved line is totally changed. It means that we have increase in the value of the speed, but with increase in the value of the time taken as well. But the small increase in the value of the speed, it means that we have increase in speed, but the value of the acceleration is not like similar to the previous graph. So this is the way how to draw the relation. It must be curved line with, so from 8 to 20 seconds, I have to draw the curved line in this way. And keep in your mind that 31 must be less than 200 meter per second when we draw from 20 to 25. So when you draw from 8 to 20, please draw the curved line in this way, but slightly less than the 200 meter per second for the speed. And for the latest section, he said, is the rocket is moving with a constant speed. There is no increase in the speed, so constant means the straight line only for 5 seconds, and the value of the speed must be less than the 200 meter per second. So we get the 3 marks now.